Hi guys, this week we're going to be looking at properties of logarithms. So we're still going to be looking at some things that have the word log in it, but this time we're going to be going through and trying to rewrite them so it'll either tell us to expand the logarithm or condense it, so write it as multiple logs or write it as one. So the first part of our notes is going to review what we did last week. So anytime you see something that says evaluate the logarithm or change of base, so anytime you see evaluate or change of base formula, they want us to give an actual numerical answer. So for number one, it says log base 3 of 7. So this is where you're going to need Desmos or your calculator. You need to physically type in log 7 divided by log 3. And then our answer for that first one should give us 1.771. It said round to 3 decimal places, so all of these are going to have 3 decimal places in their answer. So if you have your calculator, I would try to plug a couple of these in as we go through them, just to make sure you're getting the right answer. Number 2 says log base 9 of 0.1. So 0.1 goes on the top, log of 0.1 divided by log of 9. When we type that one in, we're going to get a negative, and that's perfectly fine. So for number 2, we should get negative 1.048, and that's just telling us that if we raise that to the negative 1.048 power, 9 to the negative 1.048 power would give us 0.1. So we got a couple more. Number 3 says log base 2 of 10. So log 10 goes on the top, log 2 goes on the bottom. We type log 10 divided by log 2 in the calculator. And when we round it, we should get 3.322. Number 4 gives us a negative again. So we're putting log of 0.25 on the top, log of 5 on the bottom. When you do that division, that one gives us a negative 0.861. It's just telling us 5 to the negative 0.861 power would give us that 0.25. So I would go through and plug those in your calculator before you move on. You can pause the video, plug them in, make sure you get the answers that I got, and then when you're ready, start it up again. So the second page says they want us to find some exact values of logarithms again. So it's kind of similar to what we did on the first page, but at the top of the second page, it's telling us some properties of logs. So we're going to use these properties of logs when we get to the third page in a second and on one or two things in here. So product property is just telling us if we start out with multiplication. So if we start out with log A of u times b, we break it up into 2 logs. So log A of u plus log A of b. So it's just telling us if it starts out multiplying, we break it into addition. And the same is true for what's called a natural log. So I don't know if we've seen these yet. I don't think we saw any of these last week. Natural log is just telling us that we have a base of e. So it's just denoted by that ln. You still do it the same way. So if you see anything with ln, so ln uv, just tells us to break it apart into addition. So if it starts out multiplying, no matter if it starts out with log, if it starts out with natural log, you just break multiplying into addition. Quotient property is telling us if we start out with division, so log A of u over v, we break it into 2 logs, log A of u minus log A of v. So this time it's just telling us if we start out with dividing, we turn it into subtraction. Same is true for natural log. And then the last property is power property. So it's just telling us if we have an exponent. So we have n as our exponent in number 3 up at the properties at the top. So it says log base a of u to the n power. We move that n power to the front. So we take this exponent and we move it to the front. So when we rewrite that one, log a of u to the n power, that n just moves to the front. So we just turn it into n times log a of u. And the same is true if we have that natural log. So natural log of u to the n, just move n to the front, and it's just n times natural log ln of u. All right, so if we look at these examples on this page, the first one is just like what we did on that first page. So we need to evaluate or find the exact value of those log expressions. So log base 3 of 9, we just remember we're going to do log of 9 divided by log of 3. And our answer for that first one should give us 2. So it's just telling us 3 to the second power would give us 9. The second one is a little bit trickier, so we have to rewrite it first. So in that second one, we notice that we have an exponent on our 16. So we have log base 4 of 16 to the second power. So we just said at the top, if we have an exponent, we're going to move the exponent to the front. So first step, we're going to rewrite it as 2 times log base 4 of 16. So first step, we rewrote it. Then we're going to do what we did in our first one and on the previous page. We're going to figure out what is log base 4 of 16. So this is where we're going to need Desmos or our calculator. So we're going to rewrite log base 4 of 16 as log 16 over log 4. If you type that in your calculator, you're going to get 2. And then the only thing we have to remember here is that we had a 2 out front. So we have to do 2 times 2 to get our final answer here. So our final answer for that second one will give us 4. If you haven't gotten out your calculator or Desmos yet, I would encourage you to get it out and try to follow along on these ones, just to make sure that you got the right answer and that yours matches mine. All right, so we got a couple more. The third one says log base 2 of negative 2. If we try to type that in our calculator, so if we try to plug in log of negative 2 over log of 2, that's actually going to tell us that this one is undefined. So if you get undefined, that's fine. So if you're trying to figure out what would we raise 2 to get a negative 2, anytime you're trying to get a negative as your answer, it's going to be undefined. So that's fine there. Second to last one says ln. So ln just means natural log. ln of e to the 4.5. So this one's kind of interesting. So ln and e are inverses. So actually what's going to happen here is ln is going to cancel e, and it just gives us 4.5. So we want to write a little note by this one. ln cancels e because they are inverses. Anytime you see anything with ln and e, they're going to cancel each other, and you're just going to be left with the number. So for that fourth one, ln of e to the 4.5, ln and e cancel, and we just get 4.5. Last one on this page is going to have ln and e in it again. So what's going to happen here is ln and e are going to cancel again. So we're just going to be left with 2 and 5. So ln and e cancel each other in both of these. And then we're just left with 2 plus 5. And for that last one, our final answer just gives us 7. All right, so now we're going to get into the actual properties and expanding and using them. So anytime it says expand, so when we flip to the third page here, it says use the properties of logarithms to expand the expression as a sum, difference, and or constant multiple of logarithms. When you're looking to expand, you're usually going to have more than one log or ln in your answer. So more than one log or more than one natural log. So if we look at number one says ln of 4x. So number one is multiplying. So when we looked through the properties, we said multiplying turns into addition. So for that first one, we break it apart into 2 logs, separate it by a plus sign. So we have ln of 4 plus ln of x. And that's our final answer for that one. So in that first one, multiply turns to addition. All right, so the second one, we have an exponent. So we have log base 8 of x to the 4th. The second one's actually pretty quick. So we said whenever we had an exponent, we move it to the front of our log. So in that second one, we have log base 8 of x to the 4th, move the 4 to the front, and then we just rewrite it for log base 8 of x, and we're done. So this is our answer for number 2. That one's done, and then this was our answer for number 1. All right, number 3 has division in it. So in number 3, we have log base 5 of 5 over x. So whenever you have a fraction, that's division. Division turns into subtraction. So we just write log base 5 of 5 minus log base 5 of x. So division turns into subtraction in the middle there. So divide turns to subtract. So whenever you see division, when they want you to rewrite it or expand it as multiple logarithms, it's going to turn to subtraction. Number 4 actually has an exponent in it. So if we look at number 4, we have ln, so the natural log of the square root of z. So whenever you have a square root, that's actually an exponent of 1/2. So this square root right here is actually an exponent of 1/2. So the first thing we're going to do is rewrite it as ln of z to the 1/2. And then our last step, whenever we have an exponent, move it to the front. So our final answer for number 4 would be 1/2 ln of z. And then the last one on this page before we go through one more set of examples here. So our last one says we have ln of xyz squared. So number 5 is multiplying. So we're going to start out the same as number 1. 1 is multiplying, 5 is multiplying. So the first thing we do is break it apart to addition. So we have ln of x, ln of y, and then ln of z squared, all separated by addition. Second step, we notice that we have an exponent. So we have a 2 attached to our z. So our last step here, we have to rewrite our last natural log so that 2's in front of it. So our final answer for number 5 would just be ln of x plus ln of y plus 2 times ln of z. So last step there, we had to move that exponent to the front. All right, so just to recap really quick, if you start out with multiplying, you're going to turn it into addition. If you start out with division, you're going to turn it into subtraction. And if you have an exponent, you move it to the front of the logarithm. So that's expanding. Our last page of notes wants us to condense the expression, so it just wants us to go the other way. So in this first one, it says we have ln of 2 plus ln of x. So this time we know that we start with addition. So addition turns to multiplication. But to rewrite that first one, we have ln of 2 plus ln of x, turn it into one single natural log, so just 1 ln, and turn it to multiplication. So our final answer for number 1 is just ln of 2x. Number 2 is pretty similar, so we have addition in the middle, so we're going to turn it into multiplication. But before we can turn it to multiplication, we have to move the exponents. So we're going to have to move those exponents back before we turn it into a multiplication. So we have 2 log base 2 of x plus 4 log base 2 of y. So we move the exponents back. So we have an x squared and a y to the 4th, and then we just attach them as multiplication. So it would be log base 2 of x squared times y to the 4th in that one. So that one kind of had 2 steps. Move the exponent back, and then turn the addition to multiplication. Number 3 only has 1 step, so number 3 has 1/4 times log base 3 of 5x. Our only step here is to move the 1/4 back as an exponent. So we're going to have log base 3 of 5x to the 1/4 power. So we just make sure that we turn that into an exponent. And then the last one. So the last one starts out with subtraction. So subtraction is going to turn into division. So in that last one, we have log x minus 2 log x plus 1. So we're going to turn that into division. So just one single log. So log, and then we're going to have x divided by x plus 1 squared. So the reason our x plus 1 is squared on the bottom is because of that 2 right here. So that 2 had to become an exponent. So our final answer for that last one, number 4, is log of x divided by x plus 1 squared. All right, so you guys can slow this down, watch this again if it helps you. There are notes filled in. So if you are somebody who's a little more visual and don't want to listen to me talk, go ahead and look at those notes filled in and use it to help you on your practice this week.